Okay, so in this question, we've been presented with, effectively, we've got calcium hydroxide reacts with HNO3, which is in excess, and this produces CaNO3 and H2O. So in this case, we need to work out the mass of H2O which is produced from this reaction, right? Okay, so to work that out, you have to pay attention to what the question is actually telling us. So it tells us that the HNO3 is in excess, right? But we've been given the mass of CaOH2, right? So what we can effectively make out from that is that the limiting reagent on the left-hand side, so the reactant side of the equation, is not going to be the HNO3, it's going to be the CaOH2. The CaOH2 is what's going to be the main determinant of how much H2O is going to be produced from this reaction, right? And basically using that information, we can now effectively be confident and say, well, we're going to use the mass of CaOH2 that we've got to then work out the mass of the H2O. But we need to use some molar equations to do that. So one of the first steps I'm going to use to approach this is I'm going to, we want to be able to compare an amount of substance, right? So, and we don't have that at the moment. We have a mass in grams. I want an amount of substance in moles. So what I'm going to do is I'm going to need to work out the molar mass of CaOH2 to be able to get to an amount of substance, simply because the mass is equal to the number of moles multiplied by the molar mass, right? So I have the mass, I don't have the molar mass, I'm trying to work out the moles. So the moles would be, let's just work this out manually. So the moles would be the mass divided by, so I'm going to rearrange. So if I do MR, so you can see the moles is equal to the mass divided by the molar mass, right? So but this is what we need to work out right now, the molar mass. So we're going to refer to the periodic table to do that. So it's for CaOH2. So we've got Ca, we've got it here 40.1, OH, so 16.1, right? So let's so that would be Ca, so that would be effectively 40.1 times 1, right? So that's just from the CaOH2, so plus 2 multiplied by the oxygen relative atomic mass, so 16 plus the MR, the relative atomic mass, or in this case MR of hydrogen, which would be 1, right? So this would give us the MR of the CaOH2, right? So I'd invite you to work out what that's going to be. If you do that, you should find that you get 74.1, right? So we need to use this value now to work out the actual moles of the CaOH2, and as this equation shows, what we need to do is just simply divide the mass by the molar mass, right? So that's therefore going to be 9.29 grams divided by the MR, which is, as you saw, is going to be 74.1 grams per mole, right? Okay, so we've got these values worked out. Let's actually find out what the answer would be. If you do that on your calculator, which you should find that you get 0.125 3711, right? So that is going to be in the units of moles, right? And you can, you can work out even the units from this, right? So obviously, if you divide it in grams by a mole, something in grams per mole, the grams cancels out, and the reciprocal here changes from to the -1, which is it's like saying 1 over mole. Obviously, that is equal to just mole, right? So it's just moles. So anyway, so we now have the moles of the CaOH2. Now we need to refer back to the equation because this is obviously not necessarily what the moles of H2O is going to be. So what does the actual equation tell us? Well, what the equation tells us is that for the when we look at the ratio, so moles of CaOH2 compared to the moles of H2O, right? The equation tells us that we've got a 1:2 ratio. So for every 1 mole of CaOH2, 2 moles of H2O are produced. So this is going to be a 1:2 ratio. So therefore, that means that the N of Ca No. Actually, what we're gonna do, I don't want to complicate this. So what we're gonna do is simply, because of that, we need to just simply multiply the moles of the CaOH2 times 2 to work out what the moles of the H2O is going to be, right? Because this is the moles, so the moles of the H2O must be double because of what the equation tells us. So the moles of H2O is going to be equal to 2 multiplied by the moles of CaOH2, right? And that's going to be that's going to be 0.250 7422, and that's also in moles, right? Now, based on that, we can now calculate the mass of H2O produced, because as the equation says, the mass is simply the moles multiplied by the molar mass, right? So we need to work out the molar mass of H2O. So we can go back to effectively to the periodic table to work this out, right? So we can say the MR of H2O is going to be equal to 1, which is the relative atomic mass of hydrogen, multiplied by 2 because of the H2, plus the MR of oxygen, which is 16, right? So it's going to be 16. Now you could put 16 times 1. I mean, it doesn't really, it's the same thing, right? So so yeah, and obviously when you work that out, you're going to get 18, right? So 18, and so the MR of H2O is 18, right? So grams per mole. So I'm going to use this value now to work out the actual mass of the H2O. So the mass of H2O is going to be equal to 18 multiplied by this above number. So and yeah, I'd invite you to have a go, see what you get when you work that out. But you should get 4.51 33596, right? which is effectively, and well, why am I doing this extra step before I go into this? Do actually go into the step? The reason I'm doing this extra step is simply because of what the question asks for, right? The question says, please give your answer to a maximum of 2 decimal places. So because of that, the original answer which you have here in grams, although close to the answer, is not, it doesn't adhere to what we need to do for the particular question, which is give the answer to 2 decimal places. It's quite important, right? So so that's going to be, no, I'm not going to use that color. So 4.51, and that would be in grams, right? And that's the answer to 2 decimal places. So effectively what the questions are. So that effectively is going to be the mass of H2O produced in this reaction, right?